Hello, class. Sorry I couldn't be with you today. I wasn't feeling well, but I did want to go over this review material with you. So let's get started. Question 1 asks us what this code will return, this code right here, given this method call, check method, false, true. So false will be the value we put into x, and true the value we put into y. So let's go just from this start. We say if not x. Well, x is false, so not x would be true, which I'll just put a little t here. So that means this is definitely triggering. We can immediately skip the else, so we know that this won't be the answer. So it's going to be one of these two. All right. Then we say if y. Well, y is true, so this triggers as well, meaning we return -1. So the answer should be -1. Question 2 asks, what will this method call output given the method call yes or no true? So again, we just plug this value into my boolean. So then we check. If my boolean equals true, it just say return yes. Okay, and we'll just check real quick. This returns a string, so that should be yes right there. Question 3 asks, given the following call, what value would be returned for find the middle, and then they give us this large number. All right, so what happens is we plug this number into this integer parameter. We then see string num is equal to an empty string plus the number. This will string cast our integer, so now we can use it as a string value. And now it says int mid is equal to string num.length divided by 2. So here what we can do is we can find how long this string is, how many digits it has essentially, how many digits this numbers have, and then we're dividing it by 2 to find the midpoint. So we see this has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. If we divide that by 2, that means this mid number is 5. Okay, just keep that in mind. The mid number is 5. Then it says string num.length mod 2 equals 1. Well, the length of my string num, which is just the length of this, we already said was 10. So mod 2 would be doing 10 divided by 2 and finding the remainder. Well, since 10 is an even number, it divides evenly by 2, meaning there is no remainder. So what's going to trigger is this else condition, which says return the substring of our string num from mid -1 to mid +1. So again, this was 5, so this is the substring from 4 to 6. All right, so let's do that. We count from 0 from the left, so this is 0, 1, 2, 3, 4. So 8 is at index 4, then 9 is at index 5, and 0 is at index 6. But if you remember, the substring method is exclusive of the upper bound and inclusive of the lower bound. So it's only going to get these two numbers, 8 and 9, meaning that this last option is the answer. Question 4 asks which expression is true, and it gives us a bunch of expressions. So first, let's just go from top to bottom. It says true and not true. Well, we know the AND operation requires both values to be true, and not true is going to evaluate to false. So this is technically true and false, which would be false. Then we look over here. We have not false or not true. Well, we know the OR operation just needs one of the two to be true. Well, not false evaluates to true. Not true evaluates to false. So this is technically true or false, which evaluates to true. So right away we have found our answer. Please remember when you're doing these types of problems that we go in this order of operations when solving them. We do not, and, and then or. So that's why I always evaluated those nots first. Okay, question 5 asks, what will this code output? So we're just trying to see which of these conditions will be true. It could be either of them, it could be both, it could be neither. So let's see. First one says true and false. We're just going from left to right. True and true. This evaluates to true. And then this becomes true and false, which will evaluate total to false. So this condition does not execute. Now we'll look at this statement. Say true and 4 is equal to 2 plus 2, right? Let's just put that in parentheses there, though it will do the parentheses there because that's a Boolean expression. Well, 4 is equal to 2 plus 2. Well, yes, 2 plus 2 is 4. So this would be a true statement. So this would be true and true, meaning that this condition will execute, printing out second if statement to the console. So our answer will be this third option. Question 6 asks, what will this program print if the value of grade is 80? So let's just plug that in. The first condition says if grade is greater than 90. Well, 80 is not greater than 90, so this will not execute. Then we'll say else if grade is greater than 80. Well, 80 is not greater than 80, so this will not execute. Else if grade is greater than 70, 80 is greater than 70, so this will execute, meaning our answer is C. Question 7 asks, what will the values of x and y be after the code segment runs? So x starts off at 100, y starts off at 100. Then we check. If x is less than or equal to 100, which it is, so this executes, meaning that this will not. We say, all right, if y is greater than 100, it is not. It is exactly 100, so this will not execute. And we'll set x equal to 99. So now x is 99. All right, then we say y is equal to x plus y. Well, x is originally 100. Y is originally 100. X is 99. So 99 plus 100 is equal to 199, meaning that our answer will be this last one right here. Question 8 says, a company uses the following table to determine pay rate based on hours worked. The following method is intended to represent the table, and it says which of the following test cases can be used to show that the code does not work as intended. So basically we just need to plug these numbers in and see if it gives us the correct rate. This one says calculate rate 35. So that's in the range of 1 to 40, so it should give us $10. Let's check. If hours is less than 40, well, if we plug in 35, that is going to be true, meaning that this triggers and these two do not, and it returns 10, which is the rate that we're looking for. So this is not our answer. The next one says calculate rate 40, so we plug that in. We say 40 is less than 40. That's not true, so this is skipped. We go here. 40 is less than 50. That is true. It returns 15, which is not what we're looking for because 40 would still give us that $10 rate. So immediately our answer will be this second option. Question 9 states, assuming A and B are properly initialized Boolean values, which expression would be equivalent to the following? Not A and B. All right, so if you remember De Morgan's laws, we can distribute this not value to A and B and change the sign, giving us the expression not A or not B. So that's the first thing you should look for, which we actually do find right over here in this last option. Oh. All right, so do remember those De Morgan laws, where if you have not A and B, that is equal to not A or not B. And if you have not A or B, that is equivalent to saying not A and not B. Question 10 states a student is trying to determine if the following two expressions are equivalent. And it states what values of x and y would prove that the expressions are not equivalent. So again, it's just plugging in and evaluating. All right, so x is true, y is true. Let's try plugging those in. So we say true and not true or true. So let's do this first. We say x and not x or y. We can replace these values. So this will be true. I'll just use a capital T for and not true or true. All right, well, first we have to remember that N-A-O, no, it's like you're saying no, but you're Arnold Schwarzenegger, no. So we'll check the not first, so this will become true, and I'm just going to use 1 ampersand because that's easier. False or true. Since this is in parentheses, we'll do this first as well. So false or true, this would evaluate to true. This is true and true, which evaluates to true. All right, now let's do the other expression, which is x and not x or not y. So let's plug in these values. All right, this will be true and not true or not true. So again, we'll do the nots first. So this is true and not true or false. We're in the parentheses, so we'll evaluate that first. So this is true and not, this evaluates to true. Then we do the not, which would be true and false, which evaluates to false. So you can see that because these evaluate to two different truth values, this will prove that they are not equivalent expressions. You could also try looking at some De Morgan laws to see right away, oh, you know that this isn't going to be true. But they weren't asking you to state that they weren't true. They were asking you to prove it using two values. So just plugging in is probably the easiest way to get that done. Okay, it says given A, B, and C are properly initialized Boolean values, what values would make the following expression false? So for question 11, we're just trying to see which of these will make this false. And really the trick to this question is sort of evaluating this expression, simplifying this expression. All right, so firstly, these are a bunch of or statements. So with the or statements, we can just kind of put them together. So this will be or a, what am I saying? This will be, just annotations. This would be A or B or B or C or not A or B. Okay, and essentially because it's just a bunch of or statements, really all we need is one of these to be true and the whole statement is true. So with that, let's get rid of some of the multiples. We already have one B, so we can get rid of these two other B's. And we can simplify this expression to just be A or B or C or not A. And when you look at this, something curious pops up. We have A or not A. So at some point, we can really boil down this expression to A or not A. Because if A is true, then not A is false, and this statement is still true. But if A is false, then not A is true, and this statement is still true. So this right here will, this combination of A or not A will make this statement always true no matter what. All right, which means that our answer is this last one right over here. I zoomed out a bit so I could fit the whole question on the same page, so hopefully you can still read this. But question 12 states, in order to ride the zip line, you need to be at least 12 years old and weigh at least 75 pounds, but no more than 300. Which of the following code segments would correctly determine if you could ride the zip line? So we've just got to check these out. This one says age is greater than or equal to 12, and 75 is less than or equal to weight, which is less than or equal to 300. Okay. So problem here is that you can't do this in Java the way you can do that in your math classes. You would have to state each of these separately. So it would have to be 75 is less than or equal to your weight, and weight is less than or equal to 300. Those would have to be two separate statements, just like you see here in number 2. So that is not going to work. So option 1 is off the table, meaning that this one, this one, and this one are not possible answers. It means it can only be 2 only or 3 only. Let's take a look over here. All right, so 2 says if age is greater than or equal to 12, that is certainly a requirement. That is a well-stated thing. And then inside, we should check to see if your weight is in the proper range, which is it's greater or equal to 75 and less than or equal to 300. Yep, so this, and then it returns true. So this will definitely work, which means that we don't even need to check 3 because there is no option that includes only 2 and 3. Question 13 states, what will the following code output when executed? So let's read through this. We have string breakfast equals to a new string called pizza, string lunch equals to a new string called pizza, and string dinner equals breakfast, which we know was pizza. So someone eating pizza for every meal, very fun. This first thing checks breakfast equals lunch. Well, remember, this is only true for these strings if they are referring to the same location in memory. Now remember, breakfast locations one location in memory, lunch references a different location in memory, but dinner will reference the same place as breakfast because it's set equal to that variable. Remember, when you set things equal like this dinner becomes an alias of breakfast, meaning it points to the same location in memory. So breakfast equals lunch, that will be false. Breakfast dot equals lunch, however, this will not check to see if their memory addresses are the same. This is going to check to see if their values are the same, which it is. So this will trigger. This next if checks, is breakfast equal to dinner? It is, because they reference the same location in memory, so those two are the same. Then this one says else if breakfast dot equals dinner. Well, this would be true, but you have to remember this is an else if, and this is an else. These don't trigger because this one here did. So you have to be careful of that. This right here is a connected conditional statement. These were their own separate conditions. So because we've already determined that this first one is true, we have to skip these two. These are not going to trigger, meaning that our answer is just B, C. So right over here. Okay, question 14 states the following code is intended to return only even numbers. If an even number is passed to the method, it should return that number. If an odd number or 0 is passed, it should return the next highest even number. Does this code work as intended? Let's take a look. Okay, so first let's see if we plug in an even number. Let's just pick the number 8 and see what happens. So we say 8 mod 2 equals 0. That will trigger. So then it will return that number. So it returns itself, meaning that boom, right away, we already know that it at least does the first thing. It'll return that even number. Now let's check to see if an odd number is passed, what happens. So we'll plug in just 1. So we'll say 1 mod 2 equals 0. Well, that'll be false because 1 mod 2 is 1, so that won't trigger. We'll go to the else if. Number equals 0. That's not true. All right, 1 is not equal to 0, so we go over here. And it says else return number plus 1. So number plus 1, 1 plus 1 is 2, so that does return the next highest even number. So far so good. Now let's try plugging in 0. If we plug in 0, 0 mod 2 equals 0. Oh, well that's true, right? 0 mod 2, that's just 0 divided by 2, which would be 0 remainder 0. So that's equal to 0, meaning that it returns itself. But it shouldn't. We technically, we wanted this to trigger, but unfortunately this was also true. So this triggers first, it'll return 0, and it will never return the next highest number, which is exactly what's stated in this option here. Now this isn't part of the question, but if we wanted to fix this, all we'd have to do is swap these two statements. So it checks to see if it's 0 first, and then it'll check to see if it's any other number, because 0 will still trigger this option, but it won't if we check it beforehand, because order of operation. This next question says, given the following statements, which options will print true? So we have string Ursa, which is equal to a new string 2849, and string major, which is equal to the string 2849. So they have the same contents, but they are two different strings at two different memory locations. So let's see. System.out.println Ursa.equals major. So this is checking their contents, which are both the same. So this one will output true. That's great. System.out.println Ursa equals major. This will output false because they are two different memory locations. All right. This one will check Ursa.equals 2849. So again, this is just checking the contents of each, which they will be the same. So this will output true. And then we check major is equal to 2849, which again, two different memory addresses, that will be false. So it's only 1 and 3, which is this option right here on the bottom. Okay, question 16 says, given the following code, what will the final values of x and y be if their initial values are 12 and 5? All right, let's try this out. So x is 12, y is 5. So we check. X is greater than 12, y. It is. So y times equals 2, which means just multiply it by 2. So now y has the value 10. So this triggered, which also means any connected conditional statements will definitely not, which means this won't, this else if, and then there's no other connected ones. Now we'll check this. If x is greater than y, it is. So this will trigger, which says y times equals 2. So we multiply this by 2 again, meaning our new value of y is 20. And then any connected conditional statements will not trigger. Well, there's none, so we'll just go to this next one, which checks if y is greater than x, which at this point it is. 20 is greater than 12. So x will multiply by 2, meaning that our x will go to 24. So our values for x and y are 24 and 20, which are right here, right at the top. All right, since 17 and 18 can basically fit on the same page, let's see if I can just do them both together. Yeah, they can fit on the same page. All right, so 17 says, assuming weekday and holiday are properly initialized booleans, which expression would be equivalent to the following? So again, you're just distributing the negative and then changing the sign. That's the De Morgan law. So we distribute the negative. So we have not, weekday, and then this and will change to, so this or will change to and, not holiday, right? Well, not, those will cancel out, meaning that this should just be weekday and not holiday, which is this option right here, option 2. Okay. Then question 18 says, the following method is designed to return true if past the phrase contains either the word cat or dog. If the past phrase contains either the word cat or dog. So let's see.
and it says which of the following test cases can be used to show that it does not work as intended. Okay, so it's supposed to be true if it contains the word cat or dog. Okay, so really you're just looking to see if any of them contain those strings. If you just look at these, it says I have a dog, I don't have pets, I can catch fish, and my dog caught a cat. By the way, look at this. This is fishy. This type of question is just looking to see what tricky things you can do with strings. Because cat or dog on its own will trigger this, but also cat in another word will trigger this. Cat or dog in another word will trigger this. But the word cat doesn't exist in this string, it's just catch. But it reads these first three values and thinks, oh, there it is. So this right here will be that test string that will show that it does not work as intended. The designers will have to work on this in some other capacity. Okay, second to last, we got question 19, which says, which will the following code output when executed? So we have our string word equals elementary. So first says if word length is greater than 8. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 characters in the word elementary. So this will be true, meaning that this will trigger and it will print out long word. All right, so it's definitely not that last option. Then we'll check to see if word length is greater than 5. Well, we already know that the length is 10. So if it's greater than 8, it's definitely also greater than 5. So it needs to contain long word and medium word. So it's not this option. Then we say, else if word length is greater than 0. Well, since this one triggered, we know that this will not. And then else no word. Well, again, that's connected to this whole conditional statement, so we know that it will definitely not trigger. So long word and medium word are the two that we should see, which is this top option right over here. Okay, and the last question for the multiple choice says, what values for x and y will cause the program to execute the missing code? So this else statement. So we'll see. Let's see. If x is greater than 10. So we want this to trigger. So x needs to be some value greater than 10 at the start, which all of these are. So that's great. Then it says x minus equals 5. So remember, we're subtracting 5 from each of these values of x. And then it has to say if x is greater than 10 or y is less than or equal to 10. So both of these have to fail for us to trigger this x. So x cannot be greater than 10 when we subtract 5 from it, meaning that, okay, x is equal to 18. If we subtracted 5, it would be 13. So this can't work. This can't work. This can't work. So x has to be 12 because, because of these two options. They're the only two options where if we subtract 5, x would be less than 10 or equal to 10. All right, then it says y is less than or equal to 10. So again, we need this to be false. So that means y needs to be greater than 10, which is only in this option right here. So yeah, if we plug this in, 12 is greater than 10, but then when we subtract 5, it becomes 7. 7 is not greater than 10, and y, which is 12, is not less than 10. So this fails, meaning that this triggers executing the missing code. Okay, and now just for the short answer questions, we had 3. It says, evaluate the following Boolean expression for when A is 11, B is 7, and C is 8. So we just can plug these values in. 11 is less than 5. We can see that that will be false. Then we say B is greater than 10. 7 is not greater than 10, so we'll see that that is false. And C is equal to 3, which we know that 8 is not equal to 3. So again, that is false. So this entire expression becomes false or not false and not false. So remember, we have N, A, O, do the not operations, the and operations, and then the or operations. So let's do these nots first. All right, so this becomes false or not false is true, and not false is true. Then we do our and operations. So we'll do this. True and true is true. So this gives us false or true. And then we do our or operations. False or true is true. So your answer to this would be true. All right. For, just for your sakes, I would say write true in lowercase, because in Java, if they're asking you what you're printing, it will be a lowercase true, right? Because that's how you see Boolean expressions in Java. All right, question 2 says, Sam says that the two Boolean expressions below are logically equivalent. Is he correct? Why or why not? Okay, so this is clearly a De Morgan's Law problem where we have, an and operation changing into an or operation. Now, to do that, we would either have to, distribute a negative or factor out a negative, as it were. You can go both ways. Since this one has the negative just right on the outside, it might be easier to distribute that. So we distribute that negative to this expression, A or B, and this expression, C or D, and then we change this sign. So that would give us not A or B, which is right here. The sign should change to and, which we see right there, and that should give us not C or D. So this is correct. So you could say he is correct by De Morgan's laws. These statements are logically equivalent. And that would be a suitable answer. And finally, this one says, what is the output when the following code snippet is run? So we have string 1, which creates a new string called penguin, string 2, which creates a new string called penguin, string 3, which creates a new string called polar bear, and string 4, which we set equal to string 1, meaning that string 4 will be an alias of string 1, which means that they have the same memory address stored. They're pointing at the same object. So first we do string 1 equals string 2. Now remember, equals with strings compares their memory addresses. So since 1 and 2 are two different objects, this will output false. All right. Then, in fact, let me type out as we go. That'll be easier. So the first one will output false. Then we say string 1 equals to string 3. Again, these are two different objects and two different spots in memory. So this will output, oh yeah, why don't I just write it in there? I'm silly sometimes, guys. All right, so yeah, the first one would be false. The second one would be false. Then string 1 equals string 2. Now, because they are set equal to each other, string 4 is an alias of string 1, so they point to the same point in memory, and these are true. Then we check string 1 is equals to string 2. That is correct because they have the same character values in their object. String 1 is equal to string 3. That is false because they have different characters. And then string 1 is equal to string 4. Well, this is going to be true because technically you're comparing an object to itself. So this will be false, false, true, true, false, true. All right, everyone. Thanks for sticking with me, and hopefully this review was helpful and that you'll do well on the test tomorrow. Have a great day.